crystal field splitting of an octahedral complex. Let us see how high spin and low spin complexes are formed. These are the 5 d orbitals of Fe2+. Now when Fe2+ is approached by weak field ligands like water, H2O 6 times, 6 water molecules, water ligands are coming, and they are supposed to be weak field ligands. These d orbitals will split into 2 sets. Actually, when the ligand approaches, these orbitals will increase in their energies and they split into 2 sets according to octahedral splitting. Now the lower T2G set, that is they are having lesser energy, and the EG set will be having higher energy. Now how many electrons are there in the d orbitals of Fe2+? We can see 6 electrons in here. Let us see how they will get arranged in the T2G and EG sets. The first electron will come here, second will come here, third will come here. Where will the fourth electron go? Here you can see that the splitting energy or the energy difference between the T2G set and the EG set is less. So the fourth electron will go to the higher level of EG set, and the fifth electron will also be there in the EG set. Now each of these orbitals are singly occupied. That is, 1 electron each in each of these orbitals. Now how many electrons are left? We have 1 more electron, and that electron will come here. That is, then this T2G set will start getting, the first orbital will start getting paired. So it is the fourth electron which will decide whether the complex is a high spin complex or a low spin complex. Here you can see there are 4 unpaired electrons. So it will be a high spin complex. So when the weak field ligand approaches Fe2+, the complex which will result will be a high spin complex due to the presence of these 4 unpaired electrons. Now what will happen when this Fe2+ is approached by cyanide ions? They are strong field ligands. Again, these orbitals will split, those 5 d orbitals will split into 2 sets, T2G having lower energy and EG having higher energy. Now let us put the electrons 1, 2, 3. 3 electrons are here. But if the next electron is to go to the EG set, it will have to make a big jump. That is, this splitting energy, the difference in the splitting energies is too large for the electron to go there. So what will it do? Now we have 3 more electrons left. There were 6 electrons, 3 are here. Then they will pair up. These orbitals will start getting paired. These electrons will get paired. So the remaining 3 electrons will also come into the T2G set, and those electrons will be paired, leaving this empty. So when a strong field approaches the Fe2+, we are getting a low spin complex. So it is the 4th electron which makes the difference. If the 4th electron is going to a higher level, then that will give you a high spin complex, and if the 4th electron is coming again, going back to the T2G or lower level, it starts getting paired, then you will get a low spin complex. fourth electron going to EG level. Here fourth electron in the T2G set. So that is what is making a difference between a high spin complex and a low spin complex.